Alright, in this example we're going to find the first derivative of y with respect to x, and step one of implicit differentiation is to take the derivative of each side. And so I'm going to take d dx of the left hand side and d dx of the right hand side. The derivative of y cubed is 3y squared times y prime. Derivative of y squared is 2y times y prime. The derivative of 5y is just 5 and then times y prime minus 2x. The derivative of a constant is 0. So step one is to differentiate each side. And now my job is to isolate y prime. I've got to solve for y prime. So I would first collect all terms that have a y prime in it, and then factor out the y prime. So I'm going to add 2x to each side, and I'm going to factor out a y prime. You get 3y squared plus 2y minus 5 equals 2x. I'm going to divide each side by 3y squared plus 2y minus 5. So my derivative is going to be written in terms of x and y, which is often the case when you find the derivative implicitly. If you needed to evaluate the derivative or find the slope, you would need an x-coordinate and a y-coordinate. So now let's look at finding the second derivative using implicit differentiation. So this is the same equation that we used at the very beginning, and we know that the first derivative is the opposite of x over y, but let's just kind of refresh our memory how we did that. We took the derivative of each side with respect to x, so we get 2x plus 2y times y prime equals 0. Subtracting 2x from each side, we get 2y y prime equals negative 2x. Dividing each side by 2y, we get a first derivative of negative x over y. Okay. Now I want to take the second derivative. So if I know y prime equals negative x over y, I want to find the derivative of the derivative. So I'm going to use the quotient rule. So we're going to have negative, it'll be bottom times derivative of the top, which is 1, minus the top times derivative of the bottom, and the derivative of y is y prime, all over y squared. Now there's a couple of things. One, we have a fraction, we want to simplify it as much as possible. The other thing that's important to pay attention to is that we want our function in terms of our x and y, but we don't want to have a y prime in there. So we know what y prime is equal to. Y prime is equal to negative x over y. We're going to substitute that in, and here's where we'll have to deal with some algebra. I've got a negative y minus x times negative x over y all over y squared. So after substituting the negative x over y in for y prime, because I don't want to leave a y prime in my answer, simplifying negative x times negative x over y gives me x squared over y. And I also don't want to leave my answer as a complex fraction. So what I'll do is one of the methods of simplifying a complex fraction is to multiply all terms, or the numerator and denominator, by the LCD The LCD of all fractions is y. So when I distribute the y, I'm going to get y squared. Distributing the y onto x squared over y is just x squared. In the denominator, it's going to be y times y squared, which is y cubed. So the second derivative is the opposite of y squared plus x squared over y cubed. And there's one more substitution we can make here, because in the very beginning of the problem, we said that x squared plus y squared was actually equal to 1. So this expression right here we can substitute in, and we get negative 1 over y cubed. That is the second derivative. So here's where I'll have you pause the video and try a few problems on your own. I'll have you do student practice 1 and 2 and 3. Okay, and then start up the video to check your work. Taking the derivative of each side with respect to x, the derivative of x is 1. The derivative of y squared is 2y times y prime, and the derivative of 3 is 0. Subtracting 1 from each side gives me 2y y prime equals negative 1. Dividing by 2y, or negative 2y, gives me y prime equals 1 over 2y. And there's your derivative. Alright, let's look at the second example. I want to differentiate each side with respect to x. So d dx of sine y equals d dx of x. The derivative of sine y is cosine y times y prime. The derivative of x is 1. Solving for y prime, I'll divide each side by cosine y. So y prime is either equal to 1 over cosine y or secant y. Okay, and the last one, we want to find the equation of a tangent line to the curve y squared equals 4x at the point 9, 6. And so confirming that 9, 6 is on the is a point on this curve, if I put in 6 squared is equal to 4 times 9, I get 36 equals 36. So 9, 6 is a point on the curve. I want to differentiate each side with respect to x. So d dx y squared equals d dx of 4x. So on the left hand side I'm going to get 2y times y prime equals 4. Y prime is going to equal 4 divided by 2y, or just 2 over y. And so I first, in order to find the equation of a line, you need an ordered pair, which we have, and you need the slope. And the slope of the curve is going to be 2 divided by y, and so I only use my y coordinate here. I don't need the x coordinate. So y prime of 9, 6 is going to be just 2 over 6, or 1/3. So this is my m. So I do y minus the y coordinate equals 1/3 x minus 9. And when you simplify, we're going to get y equals 1/3 x plus 3. Okay. And so this is the slope of the tangent line to the curve y squared equals 4x at the point 9, 6.